Okay, we're going to take a look at the hyperbola. It should be our last conic to take a look at here. The hyperbola, what you need to see is that the hyperbola is almost exactly like the ellipse, except it has a minus. So if you've graphed the ellipse, really the techniques that we're going to use, we're going to start out very similar to the ellipse. A couple things that we need to get out of the way here quickly. HK, just like the ellipse, is the center of the hyperbola. Okay? A is the distance to the endpoints, right, of the horizontal axis. Okay? Now, the horizontal and vertical axis will have some different names with the hyperbola, but just like the ellipse, the A, since it's always under the X, will be the distance to the endpoints of the horizontal axis. B is the distance, right, to the endpoints of the vertical axis. Okay? All of these things, it's just like the ellipse. So we need to keep those in mind. There'll be one other letter that we'll talk about here that have to do with the foci, but let's take a look at this quickly here. Below, I have two different graphs and two different equations. The hyperbola can have two different equations, and it's based on which variable comes first. Now you'll notice in the first one here, the x comes first. Okay? When the x comes first, we have what's called a horizontal hyperbola. Now it's horizontal because if you notice, it's opening side to side. Okay? Now, since it opens side to side, I'm going to go ahead and put this in blue. Okay? We'll notice that in this case our center is at 0, 0. But it opens from side to side, and when it does, because the x comes first in the equation, you'll notice that our vertices here, so vertex and a vertex, lie on my horizontal axis. Now, that horizontal axis in this case, because it opens side to side, is called your transverse axis. I'm actually going to write that, I guess, here. That's our transverse axis. Okay? Actually, I think I'll write it up here higher. That's our transverse axis in this case, because x comes first. Okay? Now, on that transverse axis, we'll have our vertices and actually our foci, which we'll get into what the foci tell us here in a minute. But the foci the foci lie inside of the hyperbola, just like they lie inside a parabola. They lie inside the hyperbola. Okay, and we need to be aware of that. Notice a couple things here. This distance right here is 2 times a. Okay, the axis there, the transverse axis, is 2 times a. That's because it's a in each direction of the center. Now, the second term here, where the y is, that's going to help us determine what we call our conjugate axis. Okay, now the conjugate axis in this case, lies vertically for 2 reasons. Pay attention to this. One, because the y comes second, or you can think the x comes first. Okay, so that determines our conjugate axis. Again, it's b in each direction, making the entire thing 2 times b. Alright? I'm actually going to erase these because we're going to need them here in a second. we're going to need this area here. But that gives us an idea of the conjugate and the transverse. So I'm going to go ahead and write this. This is the conjugate axis. Okay? There it is. Alright, now, here's the significance of the conjugate axis. I know I'm taking a while on this, but it's worth hearing. We draw in the transverse axis and the conjugate axis, and by the way, notice, here's your center. If this was an ellipse, you would just draw in your ellipse, here, like this. Okay, whatever. But the hyperbola, we won't have that. We'll have to draw our axes, and then from our axes, this is the important part, I'll put it in purple here, we will draw a box. The box, which is constructed from your axes, notice the midpoints of each side of the box are the endpoints of your axis. From there we'll construct our asymptotes. A hyperbola has two asymptotes that runs through it and tells you the basic shape of it. Okay? The asymptotes will end up giving you the shape, how wide the hyperbola is, etc. Now, we know that it opens side to side in this case because it's horizontal and the x comes first. Okay? The one thing, and we'll talk about this in some more detail, the last thing that we need to discuss here is this distance C. Okay? Now, F, which is our foci, okay, lie a distance C away from the center. And C is related to A squared and B squared in this way, which would be similar to what you saw in the ellipse, but in this case, the foci, which are C units from the center, is related to A and B in this way. C squared equals A squared plus B squared. In the ellipse, it was minus A squared minus B squared, or B squared minus A squared. But in the hyperbola, it's C squared equals A squared plus B squared. And again, that is this distance right here. This is C. Okay? Let's take a look at the vertical. Notice, we'll go a lot quicker here. The vertical, the y value comes first. So in this case, the hyperbola opens up. It's vertical. Okay? Notice in this case, since the y term comes first, our transverse axis is running vertically, which should make sense. Y, vertical, x, horizontal. And again, it should have our vertex, our vertices, and our foci on them. Okay, I'll just draw those in here. Here's our transverse axis. Okay, notice it's running vertically this time. It's, B units this way and B units that way. Our foci will also lie on them. I'll show you how we can calculate that later when we have the equation for them. But there are foci, here are vertices. Okay, our conjugate axis, because x is second here, this helps us determine our conjugate is running horizontally. Okay, in this case it's out here somewhere. And again, we use these points, our conjugate axis, we use to help us draw in the box for our asymptotes. Okay, and this will be a little more clear once we go through an example. But just know the conjugate axis, even though it's not like on the conic itself, it's used to draw in these asymptotes to help us determine, when we go to graph this stuff, the width of our hyperbola. Okay? And again, the distance C from the vertex, I'm sorry, from the center to the focus, again, C squared equals A squared plus B squared. It's a lot to look at. Let's go through some vocabulary here quickly, and this will be for reference for later. Hyperbola. Now this is the technical definition. I want to go back up here and talk about this quickly. The hyperbola is a set of all points in the plane, the difference of whose distance from two distinct fixed points, the foci, is constant. Here's what this means. I'll try to be quick about this. That if I pick some point on my hyperbola and I look at this distance 1, you don't have to I'm sorry. You don't have to calculate this or even draw this, but I'm just going to show you. If you look at those and you say, okay, here's distance 1 and distance 2. If I take distance 2 minus distance 1, it would equal anything else that I pick, the difference from that point to the foci. So if I called this distance 3 and this distance 4, well, distance 2 minus distance 1 would actually equal distance 4 minus distance 3. If I pick any point and I find the difference in those distances, the positive difference in those distances, it'll be constant. It'll equal all the same thing. Okay? That's the importance of the foci. Just felt like we needed to say that. Okay, the foci are points used in the formal definition. They always lie on the transverse axis. The distance from the center, the foci from the center, is what we call C, and it's related to the A and B values in the hyperbola equation this way, which we've talked about. Some important information here. Transverse axis is the axis determined by the variable that comes first in the equation. The transverse axis contains the vertices and the foci of the hyperbola. The conjugate axis is the axis that runs perpendicular to the transverse axis and is used to draw the box for constructing asymptotes. Right? And then the asymptotes of the hyperbola tell you the end behavior, and we're going to take a look at this quickly. But the slope of the asymptotes will always be plus or minus b over a, where b and a come from the equation of hyperbola. Let's just take a look at that real quick here. I don't know if we have a good diagram to take a look at this, but I'll try to highlight it. If slope is rise over run, okay, if slope is rise over run, you'll notice if we're looking at this asymptote right here, okay, its rise over its run, that's pretty ugly. We'll go with something else here. Let's go with this green. This rise over this run here is b over a. And so rise over run is b over a. So the same dimensions that we use to construct our box also tell us the slope of our asymptote. That should make sense. And then if you look, the other line that's running this way is negative b over a is its slope. Okay? So you can see that happening there. Okay? That's about all we can probably take of hyperbolas. Let's get on to some examples.